Let's have a look at hybrid atomic orbitals. We'll tell you the unfortunate series of events that led to them and a quick way to deal with them. We won't go into too much detail describing the actual hybridization process. It's just ugly. Let's discuss the hybridization on each atom of carbon here. When you see only single bonds, we refer to those as being sp3 hybridized. Trust me. This is a tetrahedral arrangement. There's 109.5 degrees. This would be, for example, if you had ethane with hydrogens there. Each one of these would be 109.5 degree bond angles, all of them. If you have a double bond, we referred to this as sp2 hybridized. So write sp2, sp2. This one must be sp3. I don't know if I draw it or not. Yeah, I do. Fine, so 109.5 here, but these are 120 degree bond angles, bent. If you have a triple bond, it renders it linear. And a beautiful thing to do is just make molecular models, and it comes out that way, right? If you make a molecular model of propine, like this, with the triple bond, you'll see that it goes linear. And that's what happens in reality. Most organic chemists love these Dryden or other types of molecular models, and if they're making a substance, which organic chemists seem to always be doing, and especially if it's complex, they'll have it right at their desk, and they'll like roll it around and look at it, and it's a great thing. So these are called sp hybridized orbitals. That one's sp3 because it's just single bonds, and that's a quick way to come up with the right answers. Now, why did this happen and where do these letters come from? I don't really want to go there, except to say that electron dot structures work just fine. They predict these sorts of shapes. Everything has its 4 8-valence electrons. You can show these as individual electrons and it works fine. But when people looked at it deeper and started to come up with electron configuration using orbitals, 1s2, 2s2, it incorrectly predicts how carbon would behave, and other atoms as well, but largely carbon is the one that gets all screwed up. And to fix it, they do what they call hybridize those orbitals so that it works. It's not taught in detail in several types of chemistry because of this sort of band-aid type solution nature to it. For example, AP chemistry avoids it almost entirely, and I think that's to their credit. Other forms of chemistry, IB chemistry and college chemistry, go into it in pretty excruciating detail. I'm not. I'm just going to say here's what the type of hybridization is. What's hybridized? A lot of times people think the bonds are hybridized. No, it's the atoms that are hybridized. And by the way, if you have cumulines, that means 2 double bonds. It's equivalent to a triple bond. Try making the molecular model. You see that goes linear as well. sp hybridized. So the atoms are hybridized. And single means sp3, 109.5. Double is sp2, 120. Linear is sp triple or 2 double bonds. Which ones should you know? Just those. This is a very brief introduction to hybrid atomic orbitals.